This is the Precalculus first mid-6 weeks common assessment for the 2017-2018 school year. So we're just going to go over these problems, 18 of them. This test really I didn't think was too hard, but as usual, students didn't do as well as I thought they should do. So the first one here, 1. What is the domain of the function fx equals x over x minus 3? Well, the first thing that you should notice is that we will have a discontinuity where the denominator is equal to 0. So if we set x minus 3 cannot equal 0, we're going to find our discontinuity. And if we add 3 to both sides of this inequality, we find that x cannot equal 3. And so definitely not A, definitely not D. A and D are both the same, all real numbers, effectively. So our discontinuity is where x equals 3, and that's described in this interval notation here, answer choice B. And as far as a calculator, there's calculator confirmation here. If you go to your T-inspire CX calculator, which our students had available to them on this test, you have x over x minus 3, and you should see a vertical asymptote at x equals 3, confirming B as the correct answer. Next, for the function x squared over x times 20x minus 1 times 20x plus 3, what are the exclusions to the domain? Well, basically, exclusions in this case mean the same as discontinuities. Where are the discontinuities or the breaks in the domain of this function found? Well, basically, because of the zero factor property, we can take this denominator, x times 20x minus 1 times 20x minus 3, or x plus 3, and if we set each of these factors equal to 0, or rather cannot equal 0, and then we set x minus 1 cannot equal 0, therefore x cannot equal 1, and then this one on the right here, you have quantity x plus 3 cannot equal 0, and solving for x, you have x cannot equal negative 3. And so you just look, if you're not very careful, you might pick answer choice B, which some students did. But here, C is the correct answer. And there is some confirmation on the graphing calculator, but it could be a little bit tricky. So let's look at this and be careful about it. If we go to Control I, another page, graph, we get, and the numerator here, x squared over x. Now, one thing you have to do is, in the something about T-inspire CX calculator, if you don't multiply, sometimes it'll recognize text instead. So you have x, I think it's x minus 1 times quantity x plus 3. And so you graph this, and the problem with this is you see the discontinuities at x equals negative 3 and at x equals 1, but not at x equals 0. To see that discontinuity, you can't see in the graph. If you go to a table view, press Control T to get to table view, you can see a discontinuity here. You see this at x equals 0 undefined. So we just, that confirms our earlier answer to now 3, which of the following graphs is not that of a function. One thing that you should know since Algebra 1 days is something called the vertical line test. If you draw a vertical line and you move that vertical line in this case, touches this ellipse twice. So therefore, A is our correct answer. The remaining answer choices B, C, and D are those of a function. 4. Which type of discontinuity will not likely be seen when examining graph view in a graphing calculator? Well, a non-removable discontinuity is synonymous with an asymptote, really. An infinite discontinuity, that's another type of non-removable discontinuity. Jump discontinuity is like you have a function coming along and then the function will just jump to another place. So a hole is the correct answer. Okay, you go ahead and in fact the hole was exactly this situation here in problem 2. You didn't see this discontinuity at x equals 0 because there is a hole there. You can't see you just can't see something that small, and a point, which is what a hole is essentially, is infinitesimally small. What's the domain of function 2 times quantity 4 minus x? Well, for this, if you take what's in the algebraic, if you take 4 minus x, what's inside the radical has to be greater than or equal to 0. So if we solve for this inequality, subtract 4, and we have negative x is greater than or equal to negative 4, and then we take this whole inequality and we multiply or divide by negative 1, we get x is less than or equal to 4. Now, see, we changed the direction of this inequality symbol when we multiply by negative 1. So our correct answer is going to be an interval notation, B. And again, graphically, you go to the calculator, we go to 2 times quantity x minus 4, and then we see this kind of arrangement. Actually, it was 4 minus x, wasn't it? Let's go back. Yeah, I had it wrong. Let me do 4 minus x instead. 4 minus x. There we go. That's what the thing looks like. So you have greater than negative infinity up to and including 4 with the bracket. And again, you can go to table view. If you go to table view, you see that there is no break, no error where x equals 4, y equals 0. So 4 is included in the domain. Hence, our correct answer choice B. Problem 6. Which function is increasing for all real numbers? Basically, part of it's understanding what these things do. All right, this B, answer choice B, y equals negative x, that's actually decreasing for all numbers. F of x is 1 over x, that's going to be this type of thing here where the function's decreasing until you get to x equals 0, which you don't actually reach. That's answer choice C. And then D is going to be something like this. You have a horizontal line all the way to x equals 0, and then it resumes here. So not increasing for all real numbers. This one, answer choice A, is our correct answer, and a cube root function is what this is, and it looks something like this. And let's graph this in the calculator. Go to Control I, graph. How do we graph that? If we go to Control exponent symbol, we go to the third root here of x, and we see this type of function. If you confirm the table view, you'll reinforce that A is the correct answer for that one. 7. The graph of f of x is shown below. Which statement about the graph of f of x is true? First one, f of x is decreasing on -2 to 3. So at x equals -2, we have like a maximum here, and down to x equals 3. So this one here looks like it's a correct answer, and then you can eliminate. F of x is increasing on -3 to 1. Well, no, that's decreasing. F is decreasing on 3 to 8. On 3 to 8, you're increasing. F is decreasing on 5 to 3. Well, yeah, but you know, I guess as a matter of technicality, that's true, but that's not a best statement anyway. Our best answer is at choice A. 8. For the graph of the function g of x shown below, where is a relative maximum for the function observed? And key word here, where. Okay, where is a key word? When it comes to evaluating functions, where and what, generally they're like this. You have a where, you can write that horizontally, and a what, it can be written vertically. And then you could replace like when instead of where. So when you say where, you're talking about the horizontal, the x-axis. And so you look for this maximum here. There is a relative maximum. It's the only one on the graph. And where is it observed? Well, the maximum itself is y equals 5, but where it is observed is where x equals 4. So that's a critical little trick to that one. Just the little crossword puzzle thing with the where and the what. You can do the when and the what might help you with that. 9. Which of the following functions is a parent function? Well, the parent function will be the least complicated function. So a parent function is not going to have a negative sign. A parent function is not going to have a coefficient of 2 or a divisor of 2. It is going to be the simplest, bare bones, unadorned function. In this case, this is called the reciprocal parent function. Okay. And then problem 1 is a variation of this, which was x over x minus 3. B is our correct answer. No one should get that problem wrong. 10. A vertical asymptote is what kind of discontinuity? Well, it is a non-removable discontinuity. And you know, just looking at these, answer choices A and D, you should recognize that between those two, one of those should be the right answer because they're sort of opposites of each other. So, but that's one thing. This non-removable discontinuity is similar to a vertical asymptote is a type of non-removable discontinuity. Infinite discontinuity is another way of saying the same thing. For the function x cubed plus 1x squared minus 6x, over what interval is the function decreasing? Well, there's really no easier way to do this than to go ahead and take your graphic calculator. So we go to Control I, and we get x cubed. And just to remind myself of what this is here, that's going to be plus 1.5x squared minus 6x. Minus 6x. And we graph the function. Okay, so we see there's an interval here in the middle around where the origin is, where the function is decreasing. An easy way to do this is to go to press menu 5, which is trace, graph trace, and if we go up to the left, we scroll to our maximum, which occurs where x equals -2, and then goes down to, and the y value is 10, and then it goes down to, okay, a minimum of, relative minimum of -3.5 where x equals 1. So on this one, our correct answer is going to be C. And if a test driver is going to be really nasty about this, they could say from 10 to -3.5, which were the y values over which that function was decreasing. But you say over what interval, that's like where. Okay, over what interval means x values again. Or could say, the thing might read, where is the function decreasing? And have be one of these answers, 12. Which of the following represents the end behavior for the function f of x equals 1 over x? So we've got a lot of problems in here about, I'm not going to graph that on the calculator here. That should be easy to graph. If you graph this function f of x equals 1 over x, and the function's going to look like this as you go towards positive infinity. In fact, all these answer choices here are as x approaches infinity. So what is happening here? Is y going up towards infinity? No. Is y going down toward negative infinity? No. Is y value converging on 1? Well, no, but it's going toward 0. So we call the limit as x approaches infinity of f of x. We say that that is equal to 0. D is our correct answer. 13. Again, we have a similar problem to the one we graphed a bit ago, but I think we just have the -2 added. And so we're looking for the relative minimum of the function. And I think I remember from looking at that earlier what that would be. But let's just go back and do that for so we have -2 just to be complete. And so here we have the graph. Go to menu, trace, graph trace. We have a minimum at 1, and that minimum is -5.5. So, and the temptation has put 1, but the actual value of the minimum, remember we had the where, that holds true here, doesn't it? So B is our correct answer, and D is not. D is where there is a relative minimum, or what is the x value where there is a relative minimum. 14. Which of the following functions is bounded? So you can graph these functions, and you, I hope, can remember, but even if you were not able to remember, you could graph the function. If you graph the sine function, you would see something like this. You would see an upper boundary and a lower boundary. And so when you have an upper boundary like this, in conjunction with a lower boundary like this, you just summarize by saying bounded period. So A is our correct answer for problem 14. Problem 15, this is one that gave students a fair amount of trouble. One thing you have to realize when you do something like this, or would help you to realize anyway, when you can look at the highest powered exponents, in this case the numerator and denominator. So we're going to focus in on this portion of it, the 5x squared over the 2x squared. Because as we go toward positive infinity or negative infinity, all these other things, the negative 6x plus 7 and plus 10x are going to wash out of this thing. So you can rewrite this as 5, and toward infinity, we're going to call this infinity squared in the numerator. In the bottom, it's 2x squared. We're changing it to 2 infinity squared. And what happens here? Well, infinity over infinity cancels each other out, and we have left 5 over 2. And D is our correct answer for that. As far as a calculator supplementation, if you go to, like, let me do this here. Okay, we put in 5x squared plus, is it 6x plus 7? Is that what it is? Minus 6x plus 7 over plus 10. Not that that's going to make any difference. Over 2x squared plus 10x. So we graph this, we look at it. You know, I think we're going to have an asymptote as you go to the left, but it looks like the right is closer to what the asymptote is. And the thing is going to approach, you can go to Control T, and you can just scroll like this if you want to go faster. Okay, we're getting above 2 now. You can go faster to what you're looking for. You can go to your table view here and go to your menu and go to table, and you can edit table settings, and you can do a table step of a really large number, say 1,000, and go down. And when you do that, you're going to be able to see, okay, we're getting close to 2.5, right, as we go up into the thousands. So 5 over 2 is our correct answer on this one. Next, the free response sections. The function h of x equals x times quantity x times quantity x minus 1 times quantity x plus 3 contains how many discontinuities? Well, we can have a discontinuity where x equals 3, also where x equals 1, also for where x equals negative 3. So there are going to be 3 discontinuities here, and you can just put plus 3 or not. The calculator will assume plus, and that's it. Okay. If you graph this in the calculator, the discontinuity where x equals 0 is not going to be visible. I think I saw a few people pick 2 for the answer on this one. Answer 3. 17. The elevation in feet of a ball thrown in the air is given by the function f of t equals 6 plus 88t minus 16t squared. To the nearest foot, what is the maximum elevation of the ball, right? Again, we're looking at what, but in the horizontal, instead of where, this time we have when. Okay, when is the time, and what is how high the thing is. So if we go to Control I, we add a graph. Oops. Helps to pick the right one here too. And then we have, just to remember what it is, 6 plus 88t. Okay. 6 plus 88x minus 16t t squared, which I'm going to write as x squared. And we graph this. You can't see it really well. We can do a graph analysis, but we can use trace like we've done earlier. We go to 5 graphs trace, and trace, and we can just go up in time. Times we go to the right, and we see a maximum. I don't know if you saw that there, but we had a maximum. You can see that. Saw the little flash, and the coordinate pair there is 2.75 comma 127. Okay, so 2.75 comma 127. Guys, again, we're looking at maximum elevation. That's going to be this value right here. 2.75 is the time when that occurs. I have to tell you, I saw some 2.75s on this. Not right. Okay, answer correct answer is 127. It is not 126. It is not 128. It is nothing other than 127. Okay, that really should have been quite easy. Last one, we have for the equation negative x squared minus 10x minus 18. Where is the maximum of the graph located? Again, where? And the value, the maximum itself, okay, would be this what? What is the y value? But where would be this x value? So if we go to our calculator, negative x squared minus 8x minus 18. So we graph this function. Was that right? Negative x squared minus 8x minus 18. That doesn't look right. Doesn't look like what I remember. Minus 10x minus 18. Okay, let's fix that. I'm going to go replace that with negative 10. Okay, I think that's right now. We graph, and if you go to trace like we've done in some of these other problems, we would graph trace, and this time we can trace from the right, and we get this. Okay, at negative 5 comma 7. Well, the where, and we have negative 5 comma 7. The where is the x value. The what is going to be the y value. So what is our correct answer? Saw quite a few papers with 7 written in. Our answer is going to be negative 5. And so we're going to have to fill in our negative bubble over here, and then write in 5, and then bubble in 5 below. That's it. So I encourage you to study. There are going to be other problems, both in my test later on in the semester final, related to domain and range, and a lot of what this is an important section in that it's really covers the foundations of functions from what we're building and where we're going to go later on this year. Good luck, and thanks for viewing.